Hi, this is Math 2520, and this video is over section 12.3. We're going to be looking at areas and lengths in polar coordinates. First, for the area in the curve is given by a equals the integral from a to b of f of x, or f of x is greater than 0, and x goes from a to b. The area of a circle is a equals 1/2 r squared theta, where f of theta is equal to r. And so through the use of Riemann sums, a is equal to the integral from a to b of 1/2 f of theta squared, since that's what r is, d theta, which is equal to from a to b of 1/2 r squared d theta. Alright, so let's say we have the curve 3 minus 2 cosine 4 theta. Okay, the area is going to be from 0 to pi of 1/2 3 minus 2 cosine 4 theta squared d theta. Okay. And it's going to be, we can pull the 1/2 out, 1/2 integral from 0 to 2 pi. And we'll FOIL this out, 9 minus 12 cosine 4 theta plus 4 cosine squared 4 theta d theta. And then when we find the integral of these, we'll have 1/2 times 9 theta minus 3 sine 4 theta. Now dividing the 12 by 4 gives you the 3, plus and what we're going to do here is for the, we've done before cosine of, well, you know what, I'm going to do it in a couple steps. So let me hold on. I'll hold this up for a second. So that's going to go from 0 to 2 pi. Then we're going to be plus, and what we'll have is I'll distribute that 1/2 to the 4, so I'll have 2 integral 0 to 2 pi of cosine squared 4 theta d theta. Okay, now first let's evaluate this, and then we'll go on to evaluate the rest of it. So if we plug in 2 theta, we'll end up with 18 pi over 2, which is 9. Oh, you know what, I'm going to keep that 1/2 out right now. So we'll end up with 18 pi, and then minus, and then 2 pi, sine of 2 pi, 4 times 2 pi is 8 pi, that is just 0. So minus 0. And then minus 0 and 0 again. So we end up with just 18 pi. Everything else is zeros when we take the limits there. Alright. And so this ends up, this first part ends up being just 9 pi. Okay. Now this section here, we did do this before in Calc 1, and the way it ends up being is you'll get 4 theta plus 1/8 sine of 8 theta. So it's theta plus your derivative, that's where the 1/8 comes in, and then sine of 2 theta. Okay, this we used I think we used integration by parts. Right, and then we're evaluating this from 0 to pi. Right, and so for this, when we plug in 2 pi, we get 8 pi. And then plus 0. Then when we plug in 0, we get 0 for both, so we could just get 8 pi. So this ends up being 17 pi. Right, if we graph this, let me find where I put my Desmos. Maybe it's on this one. No. Right, let me just do another one. Let me close that out. R equals 3 minus 2. No, 3 minus 2 cosine 4 theta. And so it looks like that from 0 to 2 pi. And so what we're finding is the area of this inside inside the shape. So that's going to end up being 17 pi. Alright. So for the arc length, R equals F theta of theta, where theta is between A and B, so theta is your parameter. X is our cosine theta, so we'll have F of theta cosine theta for X, and Y will be F of theta sine theta. And then when we take the derivative with respect to X, I guess this one's dying too. We'll have dr d theta cosine theta minus r sine theta. Okay, again, that's going to be from a product rule. And for dy d theta, we have dr d theta sine theta plus r cosine theta. So when we find dx d theta squared and dy d theta squared equaling dr d theta, which is your Pythagorean theorem, we end up with cosine squared theta minus 2r dr d theta cosine theta sine theta plus r squared sine theta theta plus dr d theta squared sine theta theta minus 2r dr d theta cosine theta sine theta plus r squared cosine theta equaling dr d theta squared plus r squared. And so what ends up happening is your length is then the integral of the square root of r squared plus dr d theta squared d theta. Okay, so your dr d theta, in this case, if we have r equals 2 cosine theta, is going to be negative 2 sine theta. And then we want to know dr d theta squared, which is going to be 4 sine squared theta. And so the length is equal from 0 to pi square root. You have your r squared, which r squared is just going to be 4 cosine squared theta plus 4 sine squared theta, which is your dr d theta squared d theta. And that's going to be equal to 0 to 2 pi square root of 4 cosine squared theta plus sine squared theta d theta. Square root of 0 to 2 pi. Your take square root of 4 is 2. Cosine square theta plus sine square theta is 1. So you have 2 d theta. And so this is equal to 2 theta from 0 to 2 pi. So that's equal to, I'm sorry, 0 to pi. I saw writing 2 pi, just have it 2 pi. So that's equal to 2 pi. Alright, so again, if we want to find the area is integral from a to b, 1/2 r squared d theta. So we're doing the integral of r equals 6 plus sine theta. We're going to do this from 0 to 2 pi. And so we'll have 1/2 6 plus sine theta squared d theta. And so we'll multiply this out. So 1/2 36 plus 12 sine theta plus sine squared theta d theta. Okay, so this will be equal to 1/2 36 theta minus 6 cosine theta. Oh, I don't know why I divided that by 2. Minus 12 sine cosine theta. Plus the integral from 0 to 2 pi of 1/2 1 minus cosine squared theta. And so this is going to be, and this again goes from 0 to 2 pi. Oh wait, no. Yeah, 0 to 2 pi. Alright. So 1/2 72 pi minus 2 pi is 1, so minus 12 minus 0, and then 0 will be just 1, so it'll be negative 12. So that's that first part here. And then this one is going to be integral from 0 to 2 pi of 1/2 minus integral from 0 to 2 pi of cosine squared theta. So let's do this. We will have 36 pi. I'm going to distribute that 1/2, and then negative 12 and positive 12 cancel out, so we have just 36 pi there. Plus 1/2 theta from 0 to 2 pi. And then this part here from our parts, integration by parts, would be 1/4 theta minus sine of 2x over 2 which is 0 to 2 pi. So we'll get 36 pi plus pi and plus pi over 2. And then this is going to be sine of 4 pi, which is 0, and then when we plug in 0, you get 0. And so we'll end up with 37 pi plus pi over 2, which is about 74 pi over 2 plus pi over 2, which is going to be 75 pi over 2. I swear, this always wants to save at the very end of the problem. So I can't even move on to the next one. Or it decides to save when I have to erase something real quick. And then it's like, oh, well, I'm going to save real quick. Because even though you're making a change, so 75 pi over 2. Right. So if r is equal to 6 cosine 3 theta, then we can write this as 0 to 2 pi, 1/2 cosine 6 cosine 3 theta squared d theta. And so this would be equal to, from 0 to 2 pi, 1/2 36 cosine squared 3 theta d theta. So let's do some simplification. I'll bring out 18, 0 to 2 pi cosine squared 3 theta d theta. Alright, so this is going to be 18, 0 to 2 pi. Cosine squared is 1/2 1 plus cosine of 2 theta, so it'll be of 6 theta d theta. That's just a trig identity. And so that'd be equal to 9 integral from 0 to 2 pi of 1 plus cosine 60. Oh, I'm sorry, cosine 6 theta d theta. Right, so 9 times theta plus sine of 6 theta over 6 evaluated from 0 to 2 pi. And so this would be 9 2 pi, and when I put 2 pi in sine, I get 0. And everything else is 0, so 9 times 2 pi, so 18 pi. Alright, and the last one, if I want to do the arc length, r equals 8 cosine theta, dr d theta is -8 sine theta, dr d theta squared is 64 sine squared theta, and then r squared is 64 cosine squared theta. L is integral from 0 to 2 pi of r squared plus dr d theta squared d theta. So L is equal to 0 to 2 pi of 64 square root 64 cosine squared plus 64 sine squared d theta. 64 can come out. Or I can factor it out. Cosine squared theta plus sine squared theta d theta. That is just going to be 1. And square root of 64 is 8. So we get integral from 0 to 2 pi of 16 pi d theta. So that's going to be 16 pi theta from 0 to 2 pi. 0 is just going to make that 0. So 2 pi give me 32 pi squared. Oh, you know what? Hold on. I just realized that 2 pi wasn't being multiplied. That was the limit. Alright, hold on 1 second here. I made the mistake in the second to last step, so of course it has to, you know, save right at the end and right after I made a mistake. Oh my god. There. Right. So this is not right here. I got that 2 pi thinking I was next multiplying that 8. So 0 to 2 pi of 8 d theta. And then that's going to be just 8. 0 to 2 pi of 8 d theta, which is pretty much the same thing. Okay, so when we do this, we get 8 theta from 0 to 2 pi. Okay, that will give us 8 times 2 pi, which is 16 pi. Okay. Glad I caught that. Alright, so in the next section, we'll do 12.4. We'll look at a lot of different things with shapes and the conic sections. It may be a longer video, just to warn you. I may have to do a couple parts. I'll see you then though.